Hello everybody, welcome to 2.6 of AP Calculus ABC. This is lesson constant multiple, sum/difference rules. And today this lesson is just a reinforcement of what you already know, but it's just adding a couple more things. It's gonna make things a lot easier. And so to review, constant multiple, which is you have a constant times x. That's going to give you a constant. Derivative is just a constant. Derivative of a constant is 0. And then you have the sum/difference rules, which is just finding the derivative of each term, right? You're keeping the plus and or the minus, whatever it is, but you're finding the derivative of each term. Okay. Um, maybe wondering why there's a bunch of work here. I ended the video and it just didn't save, and unfortunately I don't really have the time right now to redo this video, so I know the work may not be the prettiest or easiest to understand, but I'm just gonna scroll a little bit and hopefully my work makes sense, but I'm not gonna really go into depth or any question. Essentially, we already know most of this stuff, right? You're just trying to use a power rule as much as you can when applicable. And then constants, remember constants are 0. And then let's say you have a constant and x, like here, negative 4x, you just get negative 4. Okay, so we're going to move on to questions 11 through 13. Find the values, x values, where the function has a horizontal tangent. You remember earlier in the lesson, you should have learned that dy dx equals 0 means that there is a horizontal tangent. So horizontal tangents exist at dy dx equals 0 when your slope is 0. And that makes sense, right? And you have a graph right here, this line, your slope is 0. That is a horizontal tangent. And so we're gonna find the slope, we're gonna find the derivative of each of these functions, and then we're gonna find the zeros. Okay, f prime of x equals, so we have product and difference rule, so we're gonna find the derivative of each term. X cubed over 3, rewrite that as that is very sloppy. Rewrite that as 1 over 3 times x cubed, and then we're just gonna bring down the rest. Okay, 1/3 times x cubed. Okay, we know power rule, we bring down the exponent. 1/3 times 3 is 1. Okay, 1, and then x stays. 3 minus 1 is 2. Okay, next, keep the plus, right? Power rule for 4x squared, bring down the 2. 4 times 2 is 8. X stays. 2 minus 1 is 1. Constant multiple rule, 12x. So we keep the 12. X disappears, right? The derivative of x is 1. And then constant is 0. So we are left with x squared plus 8x plus 12. Factor this. I should probably do it a line below. Two numbers that give me 8 when added and 12 when multiplied. 4 and 4 doesn't work. 6 and 2 works. So x plus 6, x plus 2. right? 6 times 2 is 12, 6 plus 2 is 8. So when x equals -6 or -2, you have horizontal. I put horizontal asymptotes as if we're still in unit 1. Horizontal tangent. Okay, pretty simple, right? Next question. F prime of x. We have sum rule, so we're going to take each individual term's derivative. X to the fourth over 2. Remember, that's just like saying 1/2 times x to the fourth. 4 comes down, right? Power rule. So 1/2, which is the constant, times 4 gives you 2. 4 minus 1 is 3. Next, keep the plus. 3x squared plus 1/2 times x squared. 2 comes down, so 1/2 times 2 is 1. 2 minus 1 is 1, so x, and then constant is 0. So now we're going to factor out the x, right, to find the zeros. 2x squared plus 3x plus 1 x times, and then we're going to do AC method. So 2 times 1. So 2 times 1 is 2. Then we're going to divide the factors by 2. So x plus 2, x plus 1, and then divide by 2. X plus 1, 2x plus 1. So x equals 0, -1, and -1/2 is your horizontal tangents. Okay, next question. F prime of x. Okay. So if you can just tell, like, notice the pattern. If you have something in the denominator, like in this example, we have 4, and your exponent is 4, power rule is going to cancel that out. So that 4 and that 4 cancel out. So you're left with x to the third. Same thing with the next one. You have a 3 as your exponent and a 3 in the denominator. So those 3's cancel out, and then you're left with 10x squared. Again, same thing. X squared is the numerator, 2 on the bottom. So plus 21x. And then 6 over 5 is 0, right? Constant. So again, we can factor out the x. Oh man, it is not a good look. Okay. All right, x, and then we're gonna factor two numbers that give us 21, two numbers that add up to 10, -10. So x minus 7, x minus 3, x equals 0, 7, and 3. And just like that, we are going to be done with this section of the practice. Okay. Find the equations of the tangent line and the normal lines, each function. So before we went over that equation of a tangent line, it's y equals y1 plus m times x minus x1. Now the equation of a normal line is negative reciprocal, and the rest stays the same. Okay. So we need our function value. So f of 4, 3 times square root of 4 is 3 times 2. 3 times 2 is 6 plus 4 equals 10. F prime of x, remember, square root of x is always going to be 1 over 2 square root of x, unless there's a chain rule, but that comes later on. So 3 times 1 over 2 square root of x, 4 is a constant, so that stays. So equals 3 over 2 square root of x, f prime of 4. So 3 over 2 times square root of 4. That is 3 over 2 times 2, which is 3 over 4. So y equals y1, which is 10, plus 3 over 4. And then x minus x1, which is x minus 4. Okay, our normal line, everything stays the same except our slope, which is now the negative reciprocal. So instead of 3 over 4, it's going to be negative 4 over 3. All right. All right. Next question. Y equals x squared over 2 plus 3 over 2x minus 2 at x equals 8. All right. So let's find the derivative. So we're going to do dy dx. And then power rule, right? So the 2 goes in the front, which cancels out with the 2 on the bottom. So we get x, and then remember a constant rule. A constant in x is just a constant, and then a constant is 0. So minus 2 becomes 0. Okay. Now we can plug in our 8. So 8 plus 3 over 2. So that is going to be 9.5, right? 3 over 2 is 1.5. So 8 plus 1.5 is going to be 9.5. All right, next we're going to find our y of 8. Y of 8. Okay, 8 squared is 64. Over 2 is 32. Okay, 3 over 2 times 8. 3 times 8 is 24. Over 2 is 12. So plus 12. And then the minus 2, right? Okay, 32 minus 2 is 30. Plus 12 is 40. 2. So 30 plus 12 is 42. So our y of 8 is 42. So our tangent line is y equals y1. We know our y1 is 42. Slope is 9.5. And then x minus x1. Okay, so our tangent line would be y equals 42 plus 9.5, and then times x minus 8. And then for our normal line, it's the same exact thing. Let me rewrite that. It's the same exact thing, but we have reciprocal, negative reciprocal of the slope. So hopefully you can read what I wrote, but if you can't, I did y equals 42 minus 1 over 9.5 times x minus 8. All right. Next is going to be question 16. I'm going to erase this right here so that it doesn't cut into the question. Okay. 16. Let's find our f prime. 3 comes to the front. 3 minus 1 is 2. Plus 2 comes to the front. 2 times 2 is 4. 2 minus 1 is 1, so it's 4x. And then derivative of constant is 0. F prime of 2. Okay. 2 squared is 4. Negative 3 times 4 is negative 12. 4 times 2 is 8. So negative 12 plus 8 equals negative 4. All right, let's find our f of 2. 2 to the third is 8 times the negative 1 is negative 8. 2 squared is 4 times 2 is 8. And then minus 2. Negative 8 plus 8 cancels out, so it's going to be negative 2. And so our tangent line is y equals y1, so negative 2, plus our slope, which is negative 4. So plus negative 4 times x minus x1, which is 2. And then our normal line is the negative reciprocal. So -2, negative reciprocal of the slope. What is our slope? -4. So negative reciprocal is going to be positive 1 over 4. Okay. Questions 17 through 19 are going to involve us finding the left-hand limit, right-hand limit, and then we're going to see if it's differentiable, right? So if the left-hand limit and right-hand limits are equal, then we can continue, right? We can do left-hand derivative, right-hand derivative. But if the left-hand limit and right-hand limit are not equal, then we can stop there. We know that function cannot be differentiable at that x value. Okay, so let's find our left-hand limit. Left-hand limit, so we're given at x equals 5, right? So our left-hand limit is the top function because it's the limit from the left. Anything to the left of 5 is going to be our left-hand limit. So we're going to plug in, okay? So I'm using the top function. I'm going to plug in 5 into every x. Okay, minus 8 over 5. What is 5 squared? It's 25. Okay, plus 10. Okay, 10. 2 times 5 is 10, right? Negative 8 over 5. 25 goes into 5, or sorry, 5 goes into 25 5 times. So this and this becomes times 5. 10 minus 40, right? 8 times 5 is 40. So 10 minus 40 is negative 30. Plus 10 is negative 20. Okay? And now we're going to find our right-hand limit. Right-hand limit is going to be 50 minus 14. Plug in your 5. Okay. So 14 times 5, 4 times 5 is 20, and then 5 times 10 is 50. So that's going to be negative 70. 50 minus 70 is negative 20. So our left-hand limit equals right-hand limit. And now we're going to check for differentiability. So LHD is going to be derivative of the top function, right? So derivative of 2x is 2. Net minus 8 over 5 x squared. So power rule, right? We have constant, and then we can apply power rule. So 2 times negative 8 over 5 is negative 16 over 5. X stays. And we can do our RHD, our right-hand derivative, which is derivative of 50 minus 14x. It's negative 14. Okay. So now we set them equal to each other. Oh, and we have to plug in, right? So 2 minus 16 over 5 times x. What is our x? It's 5. And then equals negative 14. Well, 5 and 5 cancel out. 2 minus 16 is negative 14. So, differentiable. Okay, I'm going to erase this little part right here. We're going to move on to the next question. So we're going to find our LH limit. Again, we're going to plug in. So we're going to use the top as our LHL because it's anything less than 9. It's 30 over square root of 9. So 30, right? Minus 9 squared. 30 over square root of 9 is 3. Minus 9 squared. 9 squared is 81. So 3 minus 81. And that is going to give us, or sorry, hold on. I'm tripping. 30 over square root of 9 is 30 over 3, right? So I wrote 3 because I said 3 last. It's actually 10, right? 30 over 3 is 10. minus 81, so that's negative 71. Right hand limit, 9 squared minus 5 times 9 minus 107. Okay. So 81 minus 45, that's going to be 36. 36 minus 107 is going to be negative 71. So LHL is equal to RHL. Next, we're going to check for differentiability. Okay, so I'm going to rewrite things with powers, right, to make things easier. So 30 over square root of x, it's kind of hard to do that off the top of our heads. It's very hard. So we're going to rewrite this as a power. So 30 is our constant, right, times x to the negative 1/2. Are you wondering why it's negative instead of just positive 1/2? Well, first of all, we moved the x to the numerator, right? So now it has to be negative, and then the negative, the 1/2 comes from the square root. Okay, and then minus x squared. So now we can do power rule. 30 times negative 1/2 is negative 15. And then negative 1/2 minus 1 is negative 3 over 2. And since we have a negative, now we can bring it back down. So 3 over 2 is just the square root of, and then x cubed. Okay, minus power rule 2x. Okay, so we get negative 15 over square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. So we get negative 15 over 27. If you're wondering how I did that, it's actually harder to do 9 cubed and then find a square root. So what you can do is do the square root of 9 first and then apply the cubed. That makes things a lot easier. Okay, anyway, continuing back, minus 2x, so minus 2 times 9, so minus 18. I'm going to find our right-hand derivative. Okay, power rule. 2x minus 5. And then we're going to plug in 9, right? So 2 times 9 is 18 minus 5 is 13. So we have negative 15 over 27 minus 18 equals 13. And as you can see, this is not equal to that. You can move the 18 to the other side if you're not sure about that, but negative 15 over 27 does not equal 31. And so, no, this is not differentiable. Okay, last one, 19. Here we go. So we're going to find our LHL. 5 times 3 squared minus 2 times 3 plus 1. 3 squared is 9. 9 times 5 is 45. Negative 2 times 3 is negative 6, and then plus 1. So it should be 40. Next, we have our right-hand limit. Plug in the 3, right? So 3 times 3 squared plus, let me rewrite that, it looks like a 12. Plus 2 times 3 plus 6. 3 squared is 9 times 3 is 27. Plus 2 times 3 is 6 plus 6. 27 plus 6 is 33. Plus 6 is 39. Our left-hand limit does not equal our right-hand limit. And then that is because 40 does not equal 39. Cool. Okay, for questions 20 through 22, we're using a similar principle that we used for the last couple of questions. So we're going to continue doing left-hand limit, right-hand limit, left-hand derivative, and right-hand derivative. But this time, we're going to do that and find or solve for variables. So the variables are a and b, and we're going to solve for those. Okay, so the idea stays the same. We're going to do left-hand limit, right-hand limit, and take it from there. Okay, number 20. At x equals -1, we have this piecewise function. And then the important thing to remember is that a and b are constants, right? We're not treating those as variables. We're treating those as constants. That is when we do our derivatives, okay? So left-hand limit, we're going to plug in -1. Okay. Cube root of -1 is -1. So -1 times a plus x squared. -1 squared is +1. So +1 and then -2. That's going to be -a minus 1. I should erase that. Okay. Right hand limit, we're going to plug in -1 into our x. So -1 times b, and then the +1 stays. Okay. Now we're going to make this into a system of equations. -a is equal to, and then we're going to move that -1 to the other side, so it's +1. So -b +1, right? Because I'm making that -1 positive. Multiply both sides by -1, and this becomes b minus 2. All right, I'm going to keep that equation in mind later on. Now we're going to solve for LHD. So our left-hand derivative, remember, a and b are constants. So a stays, and then x, cube root of x is the same thing as x to the 1/3. So we're going to do a times 1/3 x to the -2/3, right? Because of our power rule. Plus power rule again. Bring the 2 down times x, and then constant is 0. Now we're going to plug in our, actually, I'm going to do this just so you guys can visualize this better. So 8 times 3, 8 times 1/3 times cube root of x squared plus 2x. Now we're going to plug in -1. -1 squared is 1, cube root of 1 is 1. So 8 times 1/3, which is the same thing as a/3. Plus 2 times x is -1, right? So plus 2 times -1, which is -2. Okay. Right-hand derivative. Remember, b is a constant. So constant times x is the derivative of that is just constant. Derivative of 1 is going to be 0, right? Because constants become 0. So our right-hand derivative is simply b. So now we can set these equal to each other. a/3 minus 2 equals b. Okay, so I actually solved for a when we were doing the left-hand limit and the right-hand limit, as you can see here. But I can simply solve for b by moving a to the 2 to the other side. Okay, so now we have two b's, right? Here and here. I'm going to plug in a/3 minus 2 equals 2 plus a. Bring that 2 to the -2 side. So -2 minus 2 is -4. A minus a/3 is 2/3a. Okay, times 3 on both sides to get rid of the fraction. Negative 12 equals 2a. A equals negative 6. Okay, now that we have our a, we also have this function right here. So b equals 2 plus a, which is now negative 6. So b equals negative 4. And just like that, we solve for a and b. That was a beautiful problem. We're going to try doing the same thing for the next problem, but that is how you solve um, for values of a and b to make a function differentiable at a given x. All right, 21 is that x equals 2, and again we have piecewise function. Left-hand limit, so it's going to be the function that is x is less than 2. We're going to plug in 2 into x, so a times 2 to the 4 plus 2 plus 4. Right-hand limit is 2b minus 5. Right now I'm just plugging in 2 into x. Okay, so here we get 2 to the 4th is 2, 4, 8, 16. 16a, and then plus 2 plus 4 is plus 6. Okay, 2b minus 5, right? We're not going to touch that right now. We're going to leave it as that. Okay, we're going to now do our derivatives. So LHD, again, remember a and b are constants. So we treat them as constants when differentiating. So we have ax to the 4th, so we can power rule that. We get 4. I should do this. So I'm going to do 4x cubed times a. Derivative of x is 1. Derivative of 4 is 0. Right-hand derivative. Actually, I'll just write it right next since it's a short one. Right-hand derivative. Derivative of anything times x is a constant. So b. Okay. Now we have to plug in our x value, right? So we plug in 2. 2 to the 3rd is 8. 8 times 4 is 32. 32a plus 1, not 11, plus 1 equals b. All right. We can either, I'm just going to plug b into this equation right here, straight up. So 16a plus 6 equals 2 times 32a plus 1 minus 5. Okay, so we can distribute on the next step. Plus 6 equals 64a plus 2 minus 5. Now we bring the constants to the left. 6 minus 2 is 4, plus 5 is 9. Bring this a's to the right side, so 16a, you subtract 16a on both sides, you get 48a. Divide by 48, you get 9 over 48 equals a. You can reduce that, divide by 3, you get 3 over 16 equals a. Okay, and then we have this equation right here that we can use to find b. So a is 3 over 16, so we're going to do 3 over 2 times a, which is 3 over 16, plus 1 equals b. So 32 times 6 times something over 16, that should pop a bell, right? 16 goes into 32 how many times? 2. So 2 times 3 plus 1 equals B. 7 equals B. And there you go. 7 equals B, and 3 over 16 equals A. All right. Last question. I'm going to start in the middle here. So I'm going to start at 21. But I'm doing question 22. It's just for space. Okay. Left-hand limit. And we're going to plug in 1, right? A over 1 squared is A. X cubed, 1 cubed is 1. So A plus 1 minus 2. Our right-hand limit is 1 squared plus B times 1. So B, and then plus 1. This becomes A minus 1 equals B plus 2. So solving for A, we get B plus 3, and then solving for B is A minus 3. Okay, we have these, and we're going to use these later. Okay, left-hand derivative. So again, A is a constant. We can rewrite 1 over x squared as x to the negative 2. Okay, and then we're going to rewrite this so we don't get confused. We can power rule, right? So x to the negative 2 comes in front. Negative 2 minus 1 is negative 3. But we can just simply rewrite as x over 3 times A plus 3x squared. And then derivative of a constant is 0. Right hand derivative, power rule, we get 2x. Derivative of constant times x is the constant. Derivative of constant by itself is 0. So now let's plug in 1. Negative 2 over 1 cubed is negative 2, right, times A, plus 3 times 1 squared is 3. And then that is equal to 2 times 1 is 2 plus B. So B equals negative 2A plus 1, right? Minus 2, minus 2. Okay. Bring this over here. So we have B can be rewritten as negative 2A plus 1 and equals A minus 3. Move the constants to the left. So 1 plus 3 is 4. A plus 2A is 3A. And so divide by 4. Sorry, it's not divided by 4, right? Because it's 3A, it's not 4A. So divided by 3, and you get A equals 4 over 3. And then we know what A is now, so we can plug in 4 over 3 for A. A is equal to B plus 3. Multiply. Actually, no, just bring the 3 to the left side. So 4 over 3. 3 written as a fraction of 3 is 9 over 3 equals B. So B equals 4 minus 9 over 3. So negative 5 over 3. So there you go. That's how you solve those questions. Okay. Now we're in the test prep. We're almost done. Question 23. Given g of x equals 2x to the fifth plus b over x squared, where b is a constant, find the value of b if g prime of 2 equals 180. B is a constant. Okay, so let's find g prime of x. Since we're given g prime of 2 equals 180, we know our x value, so we know x equals 2, and we know what our g prime of 2 is, so we're going to solve for b, right? But first, we have to find g prime of x. Power rule. 5 goes to the front. 5 times 2 is 10. 5 minus 1 is 4. Remember, b is a constant, so b goes to the front. 1 over x squared can be rewritten as x to the negative 2. So, negative 2x to the negative third. Right. It's applying power rule. So, we get x equals g prime of x equals 10x to the fourth minus 2b over x cubed. So we know our x is 2. So 10 times 2 to the fourth minus 2b over 2 to the third, which is 8. And that is 180. Okay. 2 to the fourth, 2, 4, 8, 16. 10 times 16 is 160. Minus 2b over 8 equals 180. Minus 160 on both sides. You get 2b over 8 equals 20. Times 8 on both sides. 2b equals 160. Divide by 2. B equals negative 80. B equals negative 80. That is not in the answer choices. So it's going to be E. Alright, this next one is going to require a little bit of patience and really just trying to understand everything that I'm going to do. We're going to use a calculator. And yeah, so let's get to it. Which of the following is the equation of the line tangent to the graph of f of x equals x to the 6th minus x to the 4th? Okay, so we're given f of x, and we're given that f prime of x equals negative 1, or at the point, right? So let's solve for f prime of x. F prime of x, and power rule, right? So 6 comes down times x to the 5. 4 comes down times x to the third. Okay, this problem is telling us that f prime of x right here is negative 1. Now you have to solve for this, but we're given a calculator. We cannot do this problem in our head. So we're given, so we have, right, two sides. So y1 is negative 1. Y2 is going to be our derivative, our f prime. So 6x to the 5th minus 4x to the third. Now, why are we doing this, right? Why are we putting these into y1 and y2? Well, when we find the intersection points, that's going to tell us what our x value is. So we have our f prime of x, that's negative 1. We don't have our x1 and our y1. So we're going to find our x1. So we're going to graph, and we see it intersects at one point. So we're going to do second, trace, and then 5 for intersect. Enter, enter, enter. So you enter 3 times. So our intersection point is negative 0.93355. But we're going to store this actually to make our lives easier. Store this. How do you store? Second button from the bottom, the STO and the arrow. Alpha. And you can choose any variable, but I'm going to choose A. And then enter. So now alpha A is stored as negative 0.93355, etc. Okay, that is our x value. Okay, so x1 equals, I should write it in uppercase because it's in uppercase. X1 equals alpha. Y1 is going to be equal to Y1 of alpha. So we're going to go to variables, Y variables, function, Y1. Uh, sorry, it's not y1 because we have -1 as y1, so that wouldn't work. We're gonna do, oh, we have to actually plug in our original equation because we're not finding our y prime of alpha. We're finding our y1 of alpha. So this is our y1. So we actually have to plug that in. So x to the 6th is not 6. X to the 6th minus x to the 4th, right? Okay, that is our y3. So y variables function y3 parentheses alpha, the green button, and the button right below, which is a parentheses. This is our y3 of alpha, okay? So we can store that. Hold on. So we're going to store that as alpha b. Okay. So now our y1 is going to be b. So our tangent line is going to be y equals y1, which is b, and then minus, right, our slope, or plus our slope, which is -1, times x minus x1, which is a. Let's plug this in. So b, so alpha b minus parentheses x, well, hold up, you wouldn't plug that in because you don't have x, right? So you would do, to find your, all our answers have negative x plus or minus something, right? So we're gonna do b and then -1 times negative a, so plus a. We ignore the x, right? We know that x is gonna be negative, so we're trying to find our b plus a so that we can find what this value is. So alpha b plus alpha a, and that is going to give us -1.03. So our final answer is going to be a, if this computer worked. Okay, it's going to be a. That matches with -0.31. What a nice problem, right? Pretty complicated, but as long as you remember your steps, right? You write down everything. It's as easy as that. Okay. Next problem, we have a disguised derivative. So we have limit as h approaches 0 of f of x plus h minus f of x. Okay. So we have minus f of x, right? So our f of x is going to be this part right here, right? I put the negative out, right? Because that negative is not part of 3x squared, right? Because it's f of x plus h minus, so you have to take the negative out. Okay, well, we can work with this. We're simply going to find the derivative of this at, well, at no point, right? We're just going to find the function. Power rule. 2 comes down. 2 times 3 is 6 times x. And then remember that anytime you have, let's say you have 2 here, right? Or it could be 5, it could be 10, it could be 100. If it's divided by x to the 1 power, that just becomes, it's the same thing but negative. And so our answer is going to have to be C. Oh my gosh. That is annoying. Okay. C. Wonderful. Okay. Question 26. The functions f and g are given by f of x equals x squared over 4 and g of x equals -1/2 x plus 2. There is a point on the graph of f for x is greater than or equal to 0 at which the tangent line, the line tangent to the graph of f is perpendicular to the graph of g. Find the coordinates of point P. Okay. All right. So we're given the most important thing here in this question is the fact that graph of F at this point will be perpendicular to the graph of G. Perpendicular to the graph of G. So what does that mean? Well, that means that we're going to have to find the slope here, right? The negative reciprocal, however. So G of X is negative 1/2 X, right? That is the negative 1/2 is the slope. But since it's perpendicular, it's going to be 2, right? It's going to be negative 2 over 1. That being said, that is going to be the slope of f of x. So we have to find f prime of x, and then after we find our f prime of x has to be 2, right? F prime of x has to be 2 since it's perpendicular to the graph of g when f prime of x is 2, right? Okay. Power rule. Or, well, let me just do this since there's some space. 2 comes to the front, so that just makes it 1/2 x. So we know that f prime of x has to be 2 times 2 on both sides, x equals 4. And now we have to find our f of 4, right, since it's coordinates. It's not just the x value. So f of 4 is 4 squared, which is 16 over 4. So 4 comma 4 is point P. All right, last problem. Mr. Bean is building his own swimming pool by digging up his backyard. For the first 3 days, he uses a shovel. After the third day, he uses a backhoe. The amount of dirt that has been removed in cubic feet is modeled by the function d defined above, where g is differentiable function and t is measured in days. Values of g of t at selected value of t are given in the table above. Okay. We have a piecewise function and we have a table. Interesting. Part A. According to the model D, what is the average rate of change of the amount of dirt removed over the time interval 3 is less than equal to t less than or equal to 16 days? Okay. Average rate of change. This is fairly simple. Um, well, it's not as simple because it's a piecewise function. You have 16 and 3. So, oh, that is a ugly D. Okay, d of 16 minus d of 3 divided by 16 minus 3. D of 16. Well, since it's a piecewise function, we have to look at what these x value or t values, what part of the piecewise function it falls on. 16 falls into the second one, right? 3 is less than or equal to t is less than or equal to 16. So we have to use g of t for 16. So g of 16, that's going to be our d of 16. G of 16 is 6,500. Over 13. I'm not going to bother simplifying that. And then d of 3, well, we still have to do that part, but okay, well, minus. Now we have to see which part of the domain does 3 fall on. So that still falls under g of t, right? Because 3 is not included in the top part of the piecewise function. So we have to use this, right? So minus 64.5. And I am not going to simplify that. You get the point. And then don't forget to include your units. feet per day. This is cubic, right? Cubic. Okay. Use the data in the table to approximate d prime of 10, the instant rate of change in the amount of dirt removed in cubic feet per day at time t equals 10 days. Now, if you guys remember, we did this a couple lessons ago, approximating derivatives using tables. We're going to use the point in between two intervals. So 10 is 2 from the 2 from the right of 8 and 2 from the left of 12. It's right in the middle of the interval 8 to 12, so we're going to use 8 and 12. So again, we're going to set up our average rate of change. So it's going to be g of 12 minus g of 8. G of 12 is 4050, g of 8 is 2100. Over 12 minus 8. 4050 minus 2100. I believe that's 1950. Okay. Not gonna simplify that. Um, okay. No, not asking for units. We're not gonna write units. Okay, is d continuous for 0 is less than equal to t is less than or equal to 16? Alright, so we're gonna look at our left hand limit, our right hand limit, right? Continuous. Same principle for all continuity questions. Is it continuous? Our left hand limit has to be equal to our right hand limit, has to be equal to our function value at that point. Okay. So we're going to use 3, right? Because that is what separates these functions. That is the point where it shifts. So we're going to do 20 times 3 plus 3 squared minus 3 cubed over 6. So that becomes 60 plus 9 minus 27 over 6. Right hand limit is going to be g of 3. G of 3 is 64.5. So now we have to set them equal to each other. 69 minus 27 over 6 equals 64.5. Negative 26 over 6 equals negative 4.5. If you know your fractions well, you know that this will be true, right? 6 times negative 4 is negative 24. 6 times 0.5 is 3. So negative 24 minus 3 is negative 27. So, yes. LHL equals RHL equals D of 3. Okay, find D prime of 2. Use appropriate units. D prime of 2, we're going to use the top function because 2 falls within that domain. I'm going to rewrite the equation. So D of t equals 20t Sorry, that looks very messy. D prime of t. Constant times a variable is going to be constant. Power rule for the next one. Power rule again, bring the 3 down. So 3t squared over 6, which is really 2 squared over 2. Okay, d prime of 2 is 20. 2 times 2 is 4. 2 squared is negative 4 over 2 is negative 2. So we are going to get 22, and then it says use units, feet cubed per day. And that is the end of 2.6. I hope this was very helpful. It was pretty long, but this is a very, very important lesson. So I recommend that you go back, go over any questions that you need review over, and master this concept, as it will be very important to do so throughout your calculus career. Thank you for watching. Take care.